Hi, this is Kanchana Murthy working as Assistant Professor in SNS College of Technology. In this video, we are going to see about LRU page replacement algorithm. So LRU page replacement and LRU approximation page replacement algorithms. So let's move on to the video. Yes. So to make these topics easy to understand, let's look at the comics on slide. So think of least recently used page replacement is like running a small hotel called Ramen. So the rooms are now your memory frames, and the guests are pages of data. So when the ramen is completely full and the new guest knocks on the door, how do you decide who to come inside? So to you need to find the guest who has been sitting in their room completely inactive for the longest amount of time. So that is called least recently used guest, right? So let's move on to the technical detail and see how operating system manages this. So before we talk about the specific algorithms, in my last video itself, we have discussed about the page replacement algorithm. So why we need page replacement algorithm, and its main job is to prevent over allocation of memory, right? And we want to give users massive virtual memory experience, even if the physical RAM chip inside the computer is quite small. So this completes the total separation between logical memory and physical memory. But swapping the pages back and forth, fast RAM and slow hard disk create overhead. So to fix this, operating system use the trick called modified bit. So in my last video itself, we have explained this. The modified bit is will be 0 if a page is brought into the RAM but never changed. So it will be marked as 1 uh, if we need to replace it. So we don't waste time in writing it back to the disk. So we just overwrite it. We only write it back if it was modified. So this saves massive amount of transfer time, right? So we have seen this 4 steps of using page replacement algorithm, the basics of using a page replacement algorithm in previous video itself. So now we directly look into the superstar algorithm of this lecture is called recently used algorithm. So unlike optimal algorithm, let's look into the future. LRU, that is least recently used, relies on past knowledge. So it operates on smart assumption. So if you have not used a piece of data for a long time, so you probably won't need it anymore soon. So the rule is simple. So replace the page that has not been used for longest period of time. So to do this, we must track the exact time each page was last accessed. So let's look at the reference string. So in the slide 70120 and 3042 somehow, right? So with 3 frames, our initial request is 701 to fill up the slots. So next, when 2 arrives, we look back. 1 was used just now, 0 was used before that, 7 has not been touched for the longest time because our frames are 3. So 7 gets kicked out and 2 takes its place. If you trace this entire sequence, the results are in 12 page fault. So this is significantly better than first in first out, but slightly worse than the theoretical optimal algorithm. So why I am saying it is a theoretical? Because we cannot always predict the futures, right? So it is theoretically possible, but uh, you know, practically it is unachievable. So LRU sounds greater on paper, but how does an operating system actually implement in the code? There are 2 ways. One is counter implementation, another one is stack implementation. So first is the counter implementation, right? So every single page entry in the table gets a little counter field. So every time the page is referenced by the CPU, we copy the current clock time into the counter. So when a page fault happens, and we need to change a page, the OS searches through the entire table to find the pages with the absolute smaller counter value. So the second approach is stack implementation. So here we keep a double linked list stack of page numbers. So whenever the page is referenced, we take it out for the middle of the stack and move straight to the top. So this means top of the stack is always most recently used and the bottom of the bottom is least recently used. So while updating 6 pointers on every memory access is in order is expensive. The massive advantages is that we never have to search for a victim. It always sitting right at the bottom. So best of all, LRU is the stack algorithm, meaning it never suffer from delayed assembly. So take a look at the visual representation on slide 6. So this diagram shows exactly how stack behaves when page reference occurs. Notice how pages are dynamically shuffled. So every time a page is touched, it immediately jumps to the top, right? So as a new item push their way onto the top, the older and neglected pages naturally sink lower and lower until they reach the bottom. So when the OS needs to evict the page, it simply looks at the bottom item and safely discards it. Right? So in my next video, we will be seeing about LRU approximation algorithms. So thank you for watching.